Hello everyone. Welcome to my channel Student Supportomatic. Like, share my video and subscribe to my channel for more videos. Trigonometry. Today we will study about trigonometry. So today's topics are Introduction to Trigonometry, Trigonometric Ratios and Problems on Trigonometric Ratios. So first is the definition of trigonometry. Trigonometry is derived from Greek words. So the Greek words are tri, that is means three, gon, that is sides, metron, that is measure. That is trigonometry is the three sides measure. Therefore, trigonometry is the study of relationship between the sides and angles of a triangle. Trigonometry is the study of relationship between the sides and angles of a triangle. So, when we consider a triangle, mainly we consider a right angle triangle. In trigonometry, we will consider right angle triangle. In a right angle triangle, the relationship between the sides and angles of that triangle is called the trigonometry. In a right angle triangle, we define some ratios of the sides of the triangle with respect to its acute angles. It means in a right angle triangle, one angle is 90°, therefore it is right angle triangle, and remaining two angles are acute angle. So we define the ratios of sides with respect to these two acute angles, that is called trigonometry. Observe the figure here. It's a right angle triangle. Here angle B is 90° and it is right angled at angle B. So angle B is 90° and angle A and angle C are acute angles. So we'll define ratios of sides with respect to these angles. See the figure. We just name the sides. When we consider angle A, the line opposite to that angle A is called the opposite side, and the line adjacent to that angle is called the adjacent side, and hypotenuse is always a hypotenuse side. Now we will define the ratios on with respect to the angle A, ratios of sides with respect to the angle A. So the first ratio is sine A. Sine A is equal to sine A. We will call it as sine of angle A. So we'll call it as sine A. So sine A is equal to opposite side by hypotenuse side. So we'll write it as a opposite by hypotenuse. So the line, see the figure, which is the opposite line to the angle A, that is BC, and hypotenuse side is AC. Therefore sine A is equal to opposite by hypotenuse, which is equal to BC by AC. Okay, the second ratio is cosine of angle A. So cosine of angle A, we'll write it as cos A. Cos A is always is equal to the adjacent side by hypotenuse side. So in the figure, the adjacent side to the angle A is the side AB and the hypotenuse side is AC. Therefore, the cos A is equal to adjacent by hypotenuse, that is equal to AB by AC. Now the third ratio is the tangent of angle A. So tangent of angle A, we will write it as a tan A, which is equal to, which is always is equal to opposite by adjacent. Tan A is equal to opposite by adjacent. So what is the opposite line? BC, and what is the adjacent line? AB. So tan A is equal to opposite by adjacent, that is equal to BC by AB. So the next ratio is cosecant of angle A. Cosecant of angle A, and we'll call it as cosec A. Cosec A, that is equal to 1 by sine A. Cosecant A is always is equal to 1 by sine A. Sine A means what? Opposite by hypotenuse. So cosecant is the reciprocal of sine A. It means we will write it as a hypotenuse by opposite. Therefore, the cosecant A is equal to the AC by BC. Cosecant A is equal to 1 by sine A, which is equal to hypotenuse by opposite, that is equal to AC by BC. The next ratio is secant of angle A. So secant of angle A is sec A. So that is equal to 1 by cos A. So secant A is equal to 1 by cos A. Therefore, the reciprocal of cos A, that is equal to hypotenuse by adjacent. So secant A is equal to hypotenuse by adjacent. Therefore, it is equal to AC by AB. And the last ratio is cotangent of angle A. Cotangent of angle A is called as cot A. The cot A is the reciprocal of tan A. Cot A is equal to 1 by tan A, which is equal to adjacent by opposite. Cot A is equal to adjacent by opposite. Therefore, it is equal to AB by BC. So, it is cot A is adjacent by opposite, that is equal to AB by BC. So these are the 6 ratios that we define on the sides of the triangle, right angle triangle, with respect to the acute angle. Here these ratios are defined with respect to the acute angle, angle A. Let's we observe some points. That is, sin A is equal to opposite by hypotenuse and cos A is equal to adjacent by hypotenuse. And then tan A is equal to opposite by adjacent. If we write this, tan A is equal to opposite by hypotenuse by adjacent by hypotenuse, that is dividing the hypotenuse on both the numerator and denominator, then it becomes what? Sin A by, that opposite by hypotenuse is the sin A, adjacent by hypotenuse is the cos A. Therefore, tan A is equal to what? Sin A by cos A. This is the important point you have to remember. That is the tan A is equal to sin A by cos A. Tan A is equal to sin A by cos A. So similarly, cot A is what? Cot A is equal to 1 by tan A. That is a reciprocal of the tan A. Therefore, cot A is equal to what? Cos A by sin A. Remember these 2 points. It's very important. Tan A is equal to sin A by cos A and cot A is equal to cos A by sin A. So next we will just write the ratios with respect to the angle C. So see the observe here, sin C is equal to opposite by hypotenuse. What is the opposite line to the angle C? That is AB. So sin C is equal to AB by AC. Then cos C, cos C is equal to adjacent by hypotenuse. The adjacent line to the angle C is what? BC. So BC by hypotenuse is AC. BC by AC. And tan C is equal to opposite by adjacent, that is AB by BC. Now cosecant is equal to 1 by sin C, that is the reciprocal of sin C. So AC by AB. Now secant is equal to 1 by cos C, that is equal to AC by BC, and cot C is equal to 1 by tan C, which is equal to BC by AB. Okay, so these are the ratios, trigonometric ratios with respect to the angle C. Now let's we do some problems on trigonometric ratios of a angle. Okay, so the first problem is given tan A is equal to 4 by 3. Find the other trigonometric ratios of a angle A. So here in this problem, the given is tan A only. The ratio, only one ratio is given, tan A. We have to find sin A, cos A, cosecant A, secant A and cot A. Okay, so first we will draw a triangle. Here we will define the sides, the triangle ABC. So A must be the acute angle. So tan A is equal to what? Given tan A is equal to 4 by 3. So tan A is equal to what? Opposite by adjacent. So 4 by 3 means the numerator is opposite and the denominator is adjacent. So opposite side value is 4 and adjacent value is 3. So we'll get the value of two sides, 4 and 3. Now we need the value for the hypotenuse side. To find the value of the hypotenuse side, we will use a Pythagoras theorem. So you all familiar with the Pythagoras theorem. That is, the square of the hypotenuse is equal to the sum of the squares of the other two sides. So AC square is equal to AB square plus BC square. So AC square is equal to, what is AB? AB is 3. So 3 square, and BC is 4. So it is a 4 square. 3 square is 9 and 4 square is 16. The sum of 9 plus 16 is 25. So AC square is equal to 25 and AC is equal to square root of 25. So 5 square is equal to 25. Therefore AC is equal to 5. Now we got the value for the hypotenuse side, that is the 5. Now we know the values for the three sides, 5, 4, 3. So now tan A is given. First we will write sin A. Sin A is equal to opposite by hypotenuse. So opposite value is 4 and hypotenuse value is 5. So it is 4 by 5. Next cos A. Cos A is what? Adjacent by hypotenuse. So adjacent value is 3 and hypotenuse value is 5. It is 3 by 5. The next ratio is cosecant A. So cosecant A is equal to 1 by sin A. Therefore that is equal to 1 by 4 by 5, which is equal to 5 by 4. Next ratio is secant A. Secant A is equal to 1 by cos A. Secant A is the reciprocal of the cos A. So 1 by cos A is equal to 1 by 3 by 5. 3 by 5 is the cos A value. So 1 by 3 by 5 is equal to 5 by 3. So secant A is equal to cos A. The reciprocal of the cos A is equal to 5 by 3. The last one is the cot A. Cot A is equal to 1 by tan A. So which is equal to 1 by 4 by 3. 1 by 4 by 3, that is equal to 3 by 4. So cot A is the reciprocal of the tan A. That is cot A is equal to 1 by tan A. So tan A value is 4 by 3. So the cot A is 3 by 4. So this is the first problem. Let's we see the one more problem on this type. Second problem is here. The second problem, if sin A is equal to 3 by 4, calculate cos A and tan A. So the given is sin A, that is equal to 3 by 4, and calculate cos A and tan A. So first we will draw a triangle here and indicate the sides opposite, adjacent and hypotenuse. So the given is sin A is equal to opposite by hypotenuse, that is opposite value is 3 and hypotenuse value is 4. Now we will calculate the adjacent value. So for that we use the Pythagoras theorem. So Pythagoras theorem is equal to, that is the AC square is equal to AB square plus BC square. In this equation we know the AC square value and BC square value, but we have to calculate AB. Okay. AC square is 4 square, AB square plus 3 square. Now 4 square is 16 and 3 square is 9. So 16 is equal to AB square plus 9. So we will take the 9 to the LHS. Then AB square is equal to 16 minus 9. So AB square becomes 7. AB is equal to square root of 7. So we will get the adjacent value as square root of 7. So opposite according to the with respect to the angle A, opposite value is 3, hypotenuse value is 4 and adjacent value is root 7. Now cos A, first we have to find cos A. Cos A is equal to adjacent by hypotenuse, that is equal to adjacent value is root 7, hypotenuse value is 4, root 7 by 4. Now tan A, tan A is equal to opposite by adjacent, that is equal to opposite value is 3 and adjacent value is root 7, so it is 3 by root 7. So the sign is given, we have to calculate cos and tan. For that we required adjacent value, so we calculated the adjacent value using the Pythagoras theorem. Next we find the cos A and tan A. So this is the second problem. Now here are some problems to work. So the third problem, that is in triangle ABC, right angle at B. AB is equal to 24 centimeter and BC is equal to 7 centimeter. So determine sin A cos A, and the second point sin C cos C. So first sin and cos you calculate, find with respect to angle A, and sin and cos you find with respect to angle C. Okay, this is your first problem. You solve it by yourself and comment your answer. And next, given secant is equal to 13 by 12, calculate all other trigonometric ratios. Only secant is given, you have to calculate sine, cos, tan, cot and cosecant. Okay, so the last problem is given 15 cot 8 is equal to 8. Sorry, 15 cot A is equal to 8. Find sine A and secant A. Okay, these are the three problems. You solve it by yourself and comment your answers. Thank you.